Right, in this video I'm going to be looking at finding surface area of something when we have a hole going through it. So if you look here, we've got a nice rectangular prism or a little block, and there has been a circular hole drilled through it. And yes, this is as good as my 3D art can be on my tablet, so I do apologize. So use your imagination to actually picture this as something that looks good. So with this, I'm going to start off, I'm going to use again the same idea of thinking of the different surfaces that I can touch. Okay, so with this one, if I think of it as just like a rectangular block that maybe I'm playing with in shop class, I could easily pick this block up and I can touch the left and right sides. Okay, so I'm going to look at the left and right sides first, and I'm going to do that because when I look at the left and the right side, they are simply just a nice rectangle. Okay, so I'm going to start with those ones. So I've got 4 centimeters for my length and then 10 centimeters for my width. So that's going to be 4 times 10. And then because I got the left and the right, I'm going to multiply that answer by 2. So 4 times 10 being 40, and 40 times 2 is 80. Okay, now I'm going to look at the top and the bottom. Okay, and again, I'm just going to look at the top and the bottom because when I look at the top, it is a full rectangle and the bottom would be the same. So this one is 15 by 4. Okay, so 15 by 4, and the top and the bottom are the same, so we're going to times by 2. 15 times 4 is 60, times 2 gives us 120. Okay, all right, let's do one of the difficult ones now. So I'm going to look at the front. Okay, now the front and the back are going to be the same. Okay, so I am going to times them by 2. But here's what the front and the back look like. If I look at it straight on, I would see a rectangle, and then I would see that circle, and I can see all the way through the circle to the other side. So there's a hole. Okay, unlike our other examples where we put a shape on top of another shape and it looked like it was just became part of it, we have cut out this shape all the way through. So there is a hole. So what I see on the front and the back is I see a rectangle minus a circle, right? I see a rectangle where a circle has been cut out of it. So that's what I'm going to use as my formula. Okay, so area of a rectangle, length times width. Okay, circle, pi r squared. Now if I look back at my original drawing here, the circle from the bottom to the top is 6 centimeters, so that means that my radius is half as big, so make sure you're using 3 for the radius. Otherwise we might accidentally find that the circle has a larger area than the rectangle, and that would be bad. Okay, all right, so length of that rectangle going all the way across, 15. Okay, the width is 10. And then for pi, we're going to use 3.14 as our approximation. And the radius we said should be 3. Okay, so I have 150 minus 3.14 times, and 3 squared is 9. So make sure you square the radius first. That's 150 minus, and 3.14 times 9 gives us 28.26. Now, what I do want to remind you is that while we are doing this, this is only what the front looks like. The back is going to look exactly the same. So we did all that work to find the front. We would have to do all that work again to find the back. Well, since the front and the back are the same, I can simply take my answer and times by 2, right? I need to have 2 of this shape, which is the rectangle minus the circle. So all of that we did is going to be multiplied by 2. And so 121.74 times 2 gives me now, is 243.48. Okay, all right, so I'm going to go back up to my shape now. Okay, so I'm going to color in. We've got our front and back. And so when we're looking at this shape, we've done a really good job. We've got the sides, we've got the top, the bottom, the front, the back, but there is new surface area that has been added into this shape. So yes, we cut away a circle, and we cut that circle all the way through the shape. But since we cut that circle all the way through the shape, we've now opened up new surface area that we could not touch before. So if I had a paintbrush and I was going to paint this shape, I could now paint that inside portion green. That inside portion, that part of the hole. So if we think about the hole, since it would have a circle on the top and a circle on the bottom, and it's cut all the way through, what we really did was we had a cylinder. Okay, now the formula for a cylinder, you might remember, is 2 pi r squared plus 2 pi r h. Now, you might be working with this part instead of 2 pi r h, you might remember it as pi dh, and that's because 2 times the radius is the same thing as the diameter. I like to work with 2 pi r squared and 2 pi r h because it's just nice to have that 2 pi r for the starting points for both. That's just a personal preference. Now, what did that formula mean? So if you were with me in grade 8, we spent a lot of time talking about what this formula means. If you weren't, I'm so sorry. You'll have to look up some information about a cylinder. What this formula means, pi r squared. If you look back here, that was the area that we did for a circle, pi r squared. Pi r squared, there it is, area of a circle, and then it's times 2, and that's because the cylinder has a circle on the top and the bottom. Well, I don't want this part of the formula. This part represents the 2 circles. I don't want the 2 circles because I've already dealt with the 2 circles over here. I took them away. So I don't want to add that part in. The 2 pi r h, this part is the rectangle that makes up the cylinder. So a cylinder has the 2 circles on the top and the bottom and a rectangle that wraps around the circumference of those circles. Okay? This is the part that I want to add in. That's the new part, the new surface area that I can now touch and paint green. Okay, not the circle part, but the rectangle part. So let's throw that in. So we've got 2 times pi is 3.14 times the radius, which is 3, and the height. So if we look back here, the cylinder is going from the front of the shape to the back of the shape, so it would have the same as 4, so it has the same depth as the rest of the shape. So my height there is going to be 4. Okay, so we'll fill in the 4 for the height. So 2 times 3.14 times 3 times 4, if you type that all into your calculator, that is going to give you 75.36. Okay, all right, so what I'm going to do now is I'm going to add all my stuff together. So we had 80, we had 120, we had, here it is here, 243.48, and we also had this 75.36. I'm going to add all 4 of those numbers together, and in total it gives me 518.84 centimeters squared. Okay, now that was just thinking about all the different things we can touch. Okay, that's the method I like using better, but if you want, you could have tried to work with the formulas for the 2 shapes separately. So we would have the rectangular prism, right? So if we had the rectangular prism, we would have gotten the 80 plus the 120, and then plus, if you look back in the formula, we did length times width. We had 15 times 10, but we would have the front and the back. So 15 times 10 is 150, times 2 is 300. Okay, so we could have done that to get 500 for the rectangular prism. For the cylinder, okay, the cylinder we said was 2 pi r squared plus 2 pi r h. But we're going to be taking away this 2 pi r squared part. So we have to do minus 2 pi r squared, but plus the 2 pi r h. So then you could fill in those 2 things separately. Okay, the 2 pi r squared would give you a 56.52. The 2 pi r h is still 75.36. 75.36. And if you go 500 minus 56.52 plus 75.36, you still get the 518.84 centimeters squared. So if you want to work just from formulas, you can, but you have to understand what the formula represents so that you can simply modify and adjust as needed. Okay? All right, I'm going to do another one here. So let's pretend, again, I got this nice block and I'm trying to make a tunnel. We'll say it's maybe you're building it for your toy cars. You got a little brother or sister, so you're making them a nice little tunnel for their toys. That would be very kind of you. So, same idea. I'm going to start off with the left side. So again, I'll do that one in red. So the left side and the right side are going to be these nice rectangles. Okay, so that gives us 8 times 20, and then there are 2 of them, so we're going to times by 2, and that gives us 160 times 2, which is 320. Okay, now this one works out a little bit differently. I'm going to just do the top. Okay, so the top here is 20 by 20, and I'm only going to do the top, and we're going to look at why in just a second. I'm only going to do the top to get 400. The bottom is going to look different, and I'll show you why in a sec. Then we'll do the front and the back. Okay, so the front and the back looks like this. It's got this nice little, looks like a bridge, right? So I've got a rectangle where then I'm subtracting half a circle. So it's a rectangle minus half of a circle. Okay. Now what I want to remind you of is the front and the back are the same, so I have to multiply that answer by 2. Now using distributive property, like we talked about when solving equations, that means I'm going to multiply this 2 into both things, so I'm going to get 2 rectangles. And if I have half a circle and I times it by 2, that actually just gives me a full circle. So I'm going to adjust this to make my life a little bit easier. I've got 2 rectangles minus 1 circle. And that way I don't need to divide anything by 2. My life will be a little bit easier that way. Okay, so for my front here, I would have 20 times 8. Okay, and I'm going to times that by 2 because that rectangle would get multiplied by 2. And for my one circle, so since here all the way across was 20, and on the bottom part I'm told this is equal and that's equal, that means that I have 6 centimeters is being taken away, and since 6 centimeters are being taken away, that leaves me with 14 centimeters as the diameter of my circle. Okay, so what I'm going to be working with then is 3.14 for pi times 7 squared. Okay, the radius being 7 squared. Okay, so 8 times 20 is 160 times 2 again is 320. And the 3.14 times 7 squared is 153.86. And when we subtract that from the 320, we are left with 166.14. Okay, so that is the left side, the right side, the top, and the front and the back. What about the bottom? So the bottom is a little bit tricky to think of. So the bottom here, if I was to flip this shape upside down so that the orange part is on the ground, here's what we would see. We would be able to see these 2 rectangles on either end, and we would be able to see another rectangle here. And if I was to paint them different colors, so I'd have my 2 rectangles on the sides, and that would be 3 by 20. Okay, those are the same. But the inside part would be the cylinder, right? So if you think about the cylinder wrapping around when we had the hole, that's a cylinder. Okay, so it's almost like a half pipe, right? Skateboard at a skateboard park, it's like a half pipe. So I have to do something different for this pink rectangle. It is not the same. Okay, so if I think about the bottom, I got my 2 rectangles on the side. That's not an issue. But for my pink rectangle, that's half of the rectangle in a cylinder. Okay, so I'll say the cylinder's rectangle. Okay, so my two rectangles on the side, that's 3 times 20, and I'm going to times that by 2, so that's 60 times 2, which is 120. Okay, now for the rectangle in a cylinder, normally it's 2 pi r h, but I'm going to have to divide that by 2 because I only need half of it. Since I'm dividing it by 2, I just end up getting pi r h. So that's actually not so bad to work with. Okay, so I have 120 plus 3.14 times the radius is 7 and the height is 20. Okay, so 3.14 times 7 times 20 is 439.6. And when we add, oh, sorry, I put it in the wrong spot, 120 plus 439.6. And when we add those two things together, we get 459.6. Okay? All right. So, looking at everything that we have together. Okay? So we have 320 plus 400 plus 166.14 plus the 459.6. Okay, adding all of those things together, just give me a second, I gotta do it on my calculator here, plus 320 plus 400 gives me now 1,325.74 centimeters squared. Okay. All right. So that is how we find the surface area of something where there's a tunnel. Now, one thing I want to point out, we were able to do that because we were able to pick this rectangular block up, right? We were saying that we could use it almost to play with toys. I want to give you just the exact same example, different numbers where I've said now it's meters. And if you think about this in terms of meters, this thing is massive. There is no way that you're able to pick this up. So if we poured concrete like this to make a bridge for something, okay, we would not be able to pick this up in any way, shape, and or form. And since we can't pick this up, if I was to go and paint this shape, I would be able to paint the left side and right side. I would be able to paint the top. I would be able to paint the front and the back. So all of those calculations are exactly the same. What I would not be able to paint is the bottom rectangles because I can't pick up this giant concrete block. What I could still paint is that half cylinder. Okay, so if we think back to our last question, I'm going to take this right here and I'm going to copy it. And I'm going to go back onto this one. And, oh, it's not going to let me paste it, is it? That's so rude. Okay. Let me go back here. I don't remember. So, 1325.74. Okay, that was our answer before, but that would include those bottom rectangles. So if you think about those bottom rectangles, if I was not going to include them, they were 3 by 20, each of them. So that's 60 for each, so I'd have to take away 120. So if I did all those calculations again, but instead of including those rectangles, I just didn't include them in my calculations, this is what I would have gotten. Okay, because those rectangles are not able to be touched if we think of this shape being massive, right? So that's why you have to think about your shape. You have to think, am I able to access that side? Is it fixed to the ground or is it stuck to something else? There's a question you're going to work on about a garage. The garage tells you one of the sides is stuck to the house. Well, if you're going to go and paint your garage, you're not going to paint that wall on the outside because it is attached to the house. So you would not include it. You would probably also not include the floor of the garage in your painting. right? So you have to think when you're doing surface area, is it logical that I can use this side? Can I touch this side? Can I paint this side? Am I using it? If the answer is no, don't include it in your calculations. But if you can get there, if you can paint it and it makes sense to paint it, then you include it. Okay, I hope that makes sense. I'm going to have videos for you guys that I'll post in D2L for individual questions should you need them. All right, have a good week, guys.